Well, howdy there, Internet students. This is Mr. Hermanson again. This is the retake prep. So if you didn't pass Objective 1.38, we're just going to do a little relearning here, and then you'll be ready to do that retake test. And hopefully you'll know how to do it. Okay, so this objective is basically trying to tell if there's a linear relationship in a table by using the constant rate of change, or the constant differences in the numbers. So if it's a linear situation, then you want to see that you're going up or down by the same amount in both variables, or that the ratio of the difference in the output over the difference in the input is the same. In other words, has the same slope. So here's what you need to do. You need to take the numbers and subtract them. Now on the top, and I'm just going to write a little notation what I get when I do 2 minus 1, I get 1. 3 minus 2 is 1. 4 minus 3, those are easy. Okay, and then I'm going to do 88 minus 92, which is negative 4. And so these are all going down by 4. So the constant rate of change, or slope, is the difference in the output divided by the difference in the input. So let's just write that there. Now remember, when you send me your work, I need to see these notes. So I want to make sure that you're actually learning from these videos and watching them. So difference in output, that would be just like subtracting your y values like you do when you find slope over the difference in the input. And that is your constant rate of change. Now remember, that's just another word for slope. So negative 4 over 1, which is negative 4, is the answer for this one. Okay? So you're going to do 4 more problems and find the constant rate of change. Now, sometimes the numbers will go up by the same amount each time, so it'll be pretty easy. But like on this one, you're going to have to find the change in the output, divide that by the change in the input. Okay. Now you can go ahead and pause the video and do those problems now, or you can continue to watch the video, take notes, and then come back. Okay, on the second problem here, we want to know if this is a linear relationship. And the way we're going to do that is by looking at the constant differences in the tables. I see I spelt that wrong there. No big deal. So subtract these numbers like I did before. 6 minus 5 is 1. 7 minus 6 is 1. 8 minus 7 is 1. And then you're going to subtract the y values also. So you get 4, 4, and 4. And so that is a linear relationship because the difference in the outputs divided by the difference in the input is always 4 over 1. Okay, checking this, we can see that the difference in the inputs is 1. The difference in the output here is 2. This would be negative 4. You have to do 31 minus 35. And the last one is 4. When we do the ratio of the output over the input, we get 2 over 1, negative 4 over 2, and 4 over 3. Those are not the same ratios. So this one is not linear. Okay, so it would be table A. All right, let's go to problem 3 here, or pause if you like and do those problems. For problem 3, we want to, I guess there is no problem 3. We want to do problem 4. So basically, we want to see if which of these tables shows a linear relationship. So we're just going to find those constant differences. So I'm going to do 2 minus 3, which is 1. 4 minus 2 is 2. 7 minus 4 is 3. 1 minus 7 is negative 6. 14 minus 10 is 4. Actually, that'd be negative 4. 10 minus 14. 18 minus 10 is 8. 30 minus 18 is 12. And 6 minus 30 is negative 24. Okay, now I'm going to divide those. So I have negative 4 over 1, which is negative 4. I have, actually that should be a negative 1, shouldn't it? 2 minus 3. So that'd be a positive 4. I'll just put a note over there. Here's my slopes between each of the sets of points. 12 minus, on the second one I get 8 over 2, which is 4. So that one's also 4. So far it's looking linear. 12 over 3 is 4. And negative 24 divided by negative 6 is 4. So in each of these I get 4. That is a linear table. Now just to show you that these are not linear, like if you check out the difference in the y's here, you'll see that 10 minus 5 is 5, right? 15 minus 10 is 5. These are all 5. That's starting to look linear, but 2 minus 3 is negative 1. 4 minus 2 is 2. 7 minus 4 is 3. 1 minus 7 is negative 6. And if you divide the difference in y by the difference in x, in other words, find the slope there, you get negative 5 for the first two numbers, 5 over 2 for the second two, which is 2.5, 5 over 3 for the third one. These ratios are not the same. So this one's going to be a no. Similarly here we get 2 and negative 1, 4 and 2, 8 and 3, and so I get 2 divided by negative 1, 4 divided by 2, 8 divided by 3, and 16 divided by negative 6. So those are not the same ratios again. So this is not going to be a linear relationship because there isn't a constant rate of change. All right. So finish those up, and when you get them done, send them to me via email, and I'll check them. And if they look good, I'll give you the test to redo. Good luck.